Okay, so this is the first problem from the assignment that we did in class today. I'm going to try and work it through and explain how you should do it. So we have, first off, magnesium fluoride is magnesium, and fluoride, magnesium is a +2, fluorine is a -1, so when you cross the charges, it gives you magnesium fluoride. And then lithium carbonate, same thing. Lithium is a +1. Carbonate's a polyatomic ion that's charge is -2. And when you cross the charges, you end up with Li2CO3. And they yield, that's where we put our arrow. And then magnesium carbonate. Again, magnesium is +2, carbonate is a -2, so those cancel out, and you simply have magnesium carbonate. And then we have lithium fluoride. Well, lithium is a +1, fluorine is a -1. I forgot to put a blank there for that one. So there is that. Okay, so now that we have the equation written out and I have blanks there for it, I'm going to rework this a little bit. And now let's look at exactly how many of each atom we have. So we have magnesium, fluorine, lithium, and then carbonate stays carbonate, so we're going to treat it as carbonate. And on this side we have 1 magnesium and 2 fluorines, and there are 2 lithiums, and there's 1 carbonate. And you'll notice that the carbonate is CO3, and there is only 1 CO3 over here. Even though there's a 3 right here, there's only 1 of the CO3 whole thing, so there's only 1 CO3. And over on this side we have 1 magnesium, and again we have 1 of the CO3s, and we have only 1 lithium and 1 lithium. So the magnesiums and the carbonates are balanced, the fluorines and the lithiums are not. On the left side over here we have 2 of each of those, and over here we only have 1. The cool thing is that they are in one compound right here. So all we have to do is change the coefficient there to a 2, which changes that to a 2, and it changes that to a 2. And now everything over here matches everything over here, and it is balanced. So the final answer that we should have to write down is MgF2 plus Li2CO3 yields MgCO3 plus 2 LiF. Alright, so now we're going to deal with rubidium nitrate, beryllium fluoride, yield beryllium nitrate and rubidium fluoride. So rubidium is Rb +1. Nitrate is a polyatomic ion, NO3 -1. So the charges will cross, giving us rubidium nitrate. Now if you want to put nitrate in parentheses to help you remember that it's all one thing, that's totally okay. You can do that. And beryllium fluoride, we have beryllium is a +2 and fluorine is a -1 still. And so again, we cross the charges and we are left with beryllium fluoride yield the beryllium +2 and nitrate minus 1, crossing the charges, giving us, whoops, I totally wrote the wrong thing there, so we'll erase that and go back. We have beryllium, and then NO3, and since the 2 came down, there's 2, and I ran out of room, so let's work this over. And then we're going to do plus, and the last one is rubidium fluoride, and again, rubidium is a plus 1, fluorine is a minus 1. The charges cross and cancel, leaving us with RBF. Okay, so now we're going to balance it, and so we have rubidium, nitrate, beryllium, and fluorine. This is what's involved in our reaction. And so now let's look at each side of the reaction and what we have on the left and the right. And you'll notice we're going to do the coefficient, which is 1, and multiply it by the subscript. So for rubidium, it's 1 times 1. So rubidium, there's 1. And for nitrate, we have 1 times 1. So there is 1 nitrate. And that's the common mistake that people make, is that the nitrate is all one thing, and there is only one of them. This 3 refers to the oxygens, not the whole nitrate molecule. So there's only 1 nitrate. And if we keep doing that, we have 1 beryllium times 1 is 1 beryllium. And we have 1 times 2 is 2 fluorine. So we do the same thing on the other side, and we're going to have 1 times 1 is 1 beryllium, and 1 times 2 is 2 nitrates, and then 1 times 1 is 1 rubidium, and the same for the fluorine. So now we see that the rubidiums are balanced, the berylliums are balanced, but the nitrates and the fluorines are not. So let's try and balance the nitrates first. I only have 1 over here, and I have 2 over here. So to get myself a 2, I need to put a 2 right there. And when I do that, that changes it to 2 times 1. So that becomes 2 rubidiums, and 2 times 1 is 2 nitrates. Now the problem is my nitrates are balanced now, but now my rubidiums are not. So, because I have 2 nitrates, but only 1 rubidium over there and 2 over here. So I need to have 2 rubidiums over here. So to do that, I put a 2 right here, which will change my rubidiums to 2. It also changes my fluorines, because I have 2 times 1 fluorine. Okay. So now I see that I have 2 rubidiums, 2 rubidiums, 2 nitrates, 2 nitrates, 1 beryllium, 2 fluorine, 2 fluorine. So everything is balanced. So now we need to write our final equation as 2 rubidium nitrate plus beryllium fluoride produces beryllium nitrate plus 2 rubidium fluoride. So there's the final answer there. Okay, now this one's a little bit different because it doesn't have ionic compounds. It's dicarbon hexahydride, reacts with oxygen to produce carbon dioxide and water. As I said, these are not ionic. Dicarbon hexahydride, that's using prefixes, so we know it's a covalent compound. And so this one's really simple. There is carbon, and di means 2. So that means I have 2 carbons. And then we have hydride, comes from hydrogen, and hexa means 6. So I have 6 hydrogens. This is actually a compound called ethane, but I decided to give you a different form of the name for it. And that reacts with oxygen, which is O, but oxygen is one of those lovely special elements, and I wrote that funny, so let me erase that and rewrite it. It's one of those diatomic elements, so it always gets a 2 when it's by itself. So it reacts with oxygen to produce, and then carbon dioxide, another compound with formula, or with prefixes, so that is carbon and 2 oxygen, and then water. And hopefully everybody understands what water is. So we have carbon, hydrogen, and oxygen, and again on each side over here we have 2 carbons and 1 carbon. So we have 2 carbons and 1 carbon. And then hydrogens, there's 6 hydrogens, and over here we have 2 hydrogens. So we have 6 and 2. And then we have 2 oxygens. Now oxygens are split here, so I have 2 oxygens here and 1 oxygen there, so that's a total of 3 oxygens. And on this side I have just 2 oxygens. Problems like this, it's always easier to just balance the carbons first, so let's do that. I have 2 carbons on the left and only 1 on the right, so I'm going to put a 2 right there to change my carbons to 2, and that changes my oxygens to 2 times 2, which is 4, plus 1, so oxygens now are 5 on this side. And I'm not going to worry about the oxygens because oxygen is in 2 separate compounds, so let's balance everything else first. If I have 6 hydrogens here and 2 hydrogens here, then I need to multiply those together. So what I'm going to do is put if I put a 3 right there, that gives me 3, sorry, I don't know why I wrote a 3 there because I said 3. That gives me 3 times 2, which is 6 hydrogens. So now carbons and hydrogens are balanced, but when I put that 3 right here, they gave me 2 times 2 is 4, plus 3, so now I have 7 oxygens. Well, carbon and hydrogen are balanced. I don't want to mess them up, but oxygen is royally messed up. I have 2 here and 7 here. So the only way to really do this is to multiply everything by 2. We talked about this at one point, so what I'm going to do is I'm going to multiply this by 2, multiply that by 2, and if I'm going to multiply everything by 2, I need to get rid of this, and it won't erase for me, so I'm going to make that 4, and this becomes 6. So when I multiply everything by 2, that multiplies all these by 2 also, so this all becomes 4, 12, and now that's 14, and hopefully you should be able to see that now 2 times something has to equal the 14 that I have over here. Well, that should be easy to know that that's 7. So I could rewrite this then to be 2 C2H6 plus 7 O2 produces 4 CO2 plus 6 H2O. And if we look to double check, I have 2 times 2 is 4 carbons. I have 4 times 1, that's 4 carbons. That's balanced, so carbons are good. I have 2 times 6 is 12. 6 times 2 is 12. So the hydrogens are good. And then I have 7 times 2 is 14. 4 times 2 is 8. Plus 6 is 14. So the oxygens are good. So everything is balanced. This is the most difficult one because people mess up on the writing the formulas for acids. Sulfuric acid, it does not say hydro, so we know that this comes from a polyatomic ion, and since it's ic, it comes from the 8 form of the polyatomic ion. So sulfuric acid is H plus 2, and sulfate, SO4, minus 2. So when we cross the charges, and that should be a plus 1, by the way, I don't know why I wrote plus 2. We cross the charges, which gives us H2SO4, and copper 1 chloride. Copper is Cu. The 1 tells me it's plus 1, and chloride is chlorine, which is minus 1. So the 1 and the minus 1 cancel out, so I'm left with CuCl, and they yield, and we'll go ahead and put our blanks here for that. They yield copper 1 sulfate. So again, copper 1 is still Cu plus 1. Sulfate is still minus 2. So I have Cu plus 1 SO4 minus 2. And when the charges cross, you're left with Cu2 SO4 and hydrochloric acid. I typed that wrong. That should be chloric acid. And hydrochloric acid is simply hydrogen and chlorine, which are both plus 1s. So it becomes that, HCl. So now if we write down all the stuff we have hydrogen, we have sulfate, we have copper, and we have chlorine. So, on this side of the reaction, the left side, we have 2 hydrogens, and over here we have 1 hydrogen. So that gives me two hydrogens and 1 hydrogen. Over here I have 1 SO4. Over here I have 1 SO4. So that's 1 and 1. Then on the left side I have 1 carbon, or copper, and over here I have 2 coppers. So there's 1 copper and 2 coppers. And then on this side we have 1 chlorine and 1 chlorine. So 1 chlorine and 1 chlorine. So now we need to get them balanced. Obviously the hydrogens are not balanced and the coppers are not balanced. So let's balance the hydrogens first. To do that, we are going to put a 2 right there, giving me 2 hydrogens, but that also gives me 2 chlorines. So I'm going to have to put a 2 right there, which will give me 2 chlorines, but it also gives me 2 coppers. And now we look and see that we have 2 hydrogens, 1 sulfate, 2 copper, 2 chlorine, 2 chlorine, balanced. So once again, let's write the final equation. Sulfuric acid is H2SO4 plus 2 copper 1 chloride yields 1 copper 1 sulfate plus 2 hydrochloric acids. And so that's the answer there.